Let's tackle this again. Make sure. Try not to be stupid with this. Let me make sure that I have the stream working. Where are we at? Yeah. Okay, so we are live. Hopefully you have audio, and hopefully this goes well. Okay, oh yeah, vectors. We're learning about vectors today, apparently. To create a vector called V, which contains the exact same elements as A, use the vector macro. I don't understand what the point of a vector would be if it's not mutable. Let's see. What the flippin'? Okay, hold on. So they want me to map over this. I should be able to just like, I'm assuming I should just be able to take an array as input. Okay, so there's these exclamation points. Okay. Allow you to store more than one value in a single data. Put the values next to each other in memory. Type can only store, that makes sense. They are useful when the list of items to create a vector. Okay. So I'm wondering if I could do this. Create a vector called a V. It contains the exact. Use the macro let V. This is what I'm thinking. I should be able to boop. Or can I just do boop? And that works. No. Now, when we create a vector hold specific types, yeah. If we want, Rust conveniently provides a macro which converts new vectors that hold values and give it. Okay, let's try this. So this is a macro. So, how about that? How about in Python it would be like something like this. No. Well, I know I can do, I should be able to do this, and then 0 dot dot a dot size. No, is a not. A is size, you look at, right? Size. Oh, is a size not a thing? Alright, hold on. Get the size of an array and Rust. Okay, so that works. So that. What was the secret to one of these yesterday was something of that nature. Yeah. is size in something that's mutable or immutable? How can it not be? What? Okay, whatever. So that's immutable, yeah. Well, okay, so I get, no, but this is immutable. What was some of these other students? So this one, that was the syntax I didn't understand. So, I32. So the problem is this. Okay, so I could. Do I know I can? Oh, hold on. How am I doing my syntax wrong? Let me just grab you. That's fine. Okay. But you're saying I can't expand A. Now why? So this is valid. Now is the problem. Oh, okay, so what it found was an array of elements that are 4, which instead we want what? So I want this. Let's bring this syntax. But you're like, suck a dick. Alright, I need a lot here. So what's my hint of the day? So if you use rustling, so what's my hint? In Rust, there are ways to define a vector. One way is vecnew, which creates a new vector and fills it with the push method. The second way is using the vec macro that defines your elements inside the square brackets. This way is the simplest when you exactly know the initial value. So this says contains the exact same elements as an A. Use the vector macro. I am using the macro. I just don't know how to suck these out. So what? The only things I know is this. That's a tuple. Oh, I see. So it's always 4, right? I think I understand. No? What do you want? Okay, am I overthinking this? This is always going to return 4. So let's just do it the old shitty way. Does that work? Now, how was I supposed to do this? Oh. Okay. Well, that's okay. Fair enough. I guess I was overcomplicating it. Okay. So, what are we doing here? To do, multiply each element in the input slice by 2 and push it to the output vector. Okay, so the input, so we have this. Okay. So you want me to, assuming this is just that, then we do output dot push. Okay, makes sense. Okay, an example of collecting vectors from map. You can map each element of the input slice to its value plus. If the input is 1, 2, 3, the output is collect. Okay. To do. Here we also want to multiply each one in the input slice by 2, but with iterator mapping instead of manually pushing into a vector. See an example in this function. Okay, so we have this is our properties. So this could be this. Okay. So right now what it's saying is we need to do this. This returns a new vector. So elements. No, but element. But so no. So this is what this is saying. Instead of what we did here, they just want to do this. So this was showing iterating version. This is showing how to map it. Okay, got it. Whoosh. Hell yeah. That's right. I think that's all good. Okay. The move sent. Oh my gosh, this one's gonna be a brutal one. This one's gonna be a good one. Okay. Okay. so this is a mutable thing, or immutable thing. Dropping a vector drops. Yeah, that makes sense. Oh, whoa. On. Oh, that's interesting. That's worth a read. That one's worth a read. So my lack of knowledge of Rust enums is okay. So what do we got? So okay, ownership. Ownership is a set of rules that govern how a Rust manages memory. A Rust program manages memory. All programs have to manage the way they use a computed memory while running. Some languages have garbage collections that regularly look for no longer used memory as a program runs. In other languages, the program must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership with sets of rules that a compiler checks. If any of these rules are violated, the program won't compile. None of the features of ownership will slow down your program while it's running. Because ownership is a new concept for many programs, it does take some time to get used to. The good news is the more experience you become with Rust, the rules of ownership in the ownership system, and the easier you'll find a natural development code that is safe and efficient. Keep at it. When you understand ownership, you have solid foundations for understanding the features that make Rust unique. In this chapter, you learn ownership by working through some examples that focus on very common data structures, strings. Oh my gosh. Many program languages don't require you to think about stacking the heap very often, but in a system programming language like Rust, whether a value is on stack or heap affects how the language behaves and why you have to make certain decisions. Parts of ownership will be described in relation to the stack and heap layer in this chapter. So here's a brief explanation preparation. Both stack and heap are okay. I know. So yeah, we're good. Look at roles, variable scope. Okay, so let's take a gander. Fix the compiler. So it seems to me that you would need a move command because this thing is generated. Or you just make this mutable, right? Oh no. So if I remove this, this would work, right? No. Oh, so is this a reference? Is this not? What are you? Well, so I can't make this mute. Do mute. Is that what you want me to do? But I think they're trying. Oh no, okay. Continually overthinking this problem. Semantic 2. Make both vector 0 and vector 1 accessible at the same time. So this is not doing what I thought it was doing. Is that? Okay. So you're saying I should clone it here. Not entirely sure I understand the distinction. Because if I cloned it here, it should be fine, but okay. Okay, so fix the compiler and the function without adding any new line. Adding any new lines. Without adding any new lines. What does that happen? My brain says it's something here, like you have to pass this ownership and functions. Let's pull this up. Okay. Ownership and function. The mechanic of passing a value to functions are similar to those when assigning value to a variable. Passing a variable to a function will move or copy just as assigning does. List 3.4 has an example of some annotations. Scope. Some string comes into scope here. Here something goes out of scope and drop is called back in memory speed. So taking ownership. So S does not exist after this point. Make copy. So I'm assuming S comes into scope. S's value moves into function and is no longer valid here. X moves into function, but S is copied, so it's okay to use it afterwards. Okay, that makes sense. If he is, yeah. Well, so how do? So I'm supposed to do it here. Stack only data copies. This could use integer point which we don't call clone, but X is still the reasons types as integers are known size compiled time. Entirely on stacks. So if they're on stacks, so copies of the actual value are quick to make. This means there's no reason we would prevent X from being valid after k variable Y. In other words, there's no difference between a deep and shallow copy here. So calling clone wouldn't do anything different than the actual copy. We can leave it out. There's a specialization called copy traits, which can be placed on types that are stored on stack as integers are. We called more about traits in a type information of the copy trait. Variables that use it do not move, but rather are trivial copied. I'm still valid after signing the variables. Rust won't let annotating a copy of the type or any part has implemented the drop type. If won't let annotating a type with copy if the type or any part is implemented the drop trait. If the type needs something special to happen when the value goes out of scope, and we add the copy annotation to this type, we get a compiler term error. To learn copy trait implementation, deliverables rates, and appendix C. So what type of implementation copy trait? Okay, so basically any okay. So interesting. References. Nope, I have no clue what to do here. Well, so we have two problems. Two problems I'm trying to wrestle with. Well, it's immutable. It's a mute. It needs to be mute. But I can't. Suppose that I can't. Consider changing this to a mute. Can I just do a mute? Oh, okay. So I can add to the beginning. So now, is this copying it? Or what? If I put it in as mutable, it's still not proper, right? So okay, so vec0 still does not exist. Got it. That's good. Good to know. Forward we go. Okay. Fix the compiler error only by reordering the lines in the test. Okay. What the flippin' hell? So we're getting a mutable reference. Essentially, we're getting a pointer to X and a pointer to Y. And these are vectors. I'm assuming you can't both have this privilege. This syntax is interesting. So I have to, so I can get a constant reference to X. I just can't get a. Okay. Allow Clippy pointer to arg. Okay. So fix the compiler errors without changing anything except adding or removing references. The character and... Okay, so fix the compiler without changing anything except adding or removing the removing references. Let's just remove this. Okay, so if I remove this, but then that doesn't make this. That works. But now that doesn't work. What is its problem? What is too... Can't like dereferences, right? Nothing. So this seems like it needs this. So this is a constant data. This is constant. So how the fuck... so how... If it... So the problem is this doesn't want a reference. Or does it want a reference? What is... It's expecting a... return the string. This... Well, so it's... I have no fucking clue what... Well, so I can't without changing anything except for... That would be my thought. I was clone it, but... So it's not like I can't like make you a reference. Like, that would make you a reference. Is everyone happy now? You don't want to be a reference. Okay. Now, I don't know what happened here. I'll be honest. What changes here? So you got turned into a char. Oh, no, makes sense. Okay, apparently I don't understand strings. Because this is an immutable. But this changes it. Or does it? What's that one? Oh, okay, that makes sense. Because you can't. So this is a char. Can I do something like? But isn't it? It's not. It's not an array of chars. Does this do anything? Does this literally do anything? It shouldn't do anything. Okay, not exactly sure. So that's the last one here. Okay, so when this was here. Okay, so this. Okay. Okay, I think I understand. So why this fails is because this was taking ownership, and once it took ownership, it didn't exist here. So this is taking ownership. Okay. Got it. We're cooking. We're cooking here. Okay. So, because this isn't doing anything. Shouldn't take ownership. Okay. Okay, so, okay. Okay, that makes sense. Struct. Okay, let's send it. What struct do we got? What do we got here, buds? Okay, what do needs to exist? We need green. So we have unions and structs. Add fields. What does a struct look like? I have no clue. Okay. So green. Okay. Okay. So I need. So yeah, a red is a U8. Green is a U8, and blue is a U8. So now I can do red 0, red green equals 0, blue equals 0. Whoosh. Okay, so can I construct it like dot 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 dot? No. Color tuple struct. Add the fields. Add a tuple struct. So your color tuple struct. Tuple. What does it look like? U8, U8, U8. Oh. Okay, that makes sense. To do initiate a unit struct. A unit struct, what does that mean? What does a unit struct mean? Unit like structs without any fields. You can also define structs that don't have any fields. They're called unit structs because they behave similar to what? Parentheses. What function? The unit types that we mentioned in tuple type section. Unit-like structs can be useful when you need to implement a trait on some type but don't have any data that you want to store in the type itself. We discussed in chapter 10. Here's an example declaring an instant struct name. Not entirely sure what that accomplished. What does this mean? To define equivalent, we use the struct keyword, the name we want, and then a semicolon. No need to curly braces. Then we can get an instance of always equal in the subject variable in a similar way. Using the name we define without any curly braces, parentheses, mentioned later, we implement behaviors for this type, such as that every instance of always equal is always equal to every instance of any other type. Perhaps to have a known result for testing purposes. We wouldn't need any data to implement for that behavior. You see chapter 10. Okay, that's something I need a hint on this one. They don't have any fields or are useful for generics. Yep. One big blank right now. What? 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 There's something here. There's something. So somehow the unit struct should just print itself out, is what I'm assuming. What does this print out, I guess? Can I do that, or do I have to do... Unit structs are fun. Seems fine. Oh! I failed the regular struct. Oh, that makes sense. Okay, got it. Yep. Yeah, okay. Okay, what's next? Bush. Okay, so we got some structs. We got some goodies. An order. We have an order template. We have a main. Create your order. So we're going to use this as a your order. Well, oh, I see. With the update syntax. So okay, so your code So this just do I clone it? Do I, what's the update syntax? Okay, so this is pretty JavaScripty. Just shut up for 2 seconds here, kid. Okay, so name. Oh no, so this, this. Can you shut up for 2 seconds? Okay. Notice that order this count to 0, so alright, what do we got? Let's bring it on. Let's up that hour so we can finish this up. Crush out another 3 of these puppies. Okay. So structs contain data but can also have logic. And in this exercise we have defined package struct and we want to test some logic attached to it. Oh my gosh, this is a big one. This is a big one. Okay, so so they created struct, and then this is okay. This is how we should handle errors in Rust, but we'll learn about error handling later. Okay, so this is how. Oh my gosh, this is. Oh no, but no. Oh, this is weird syntax. Okay. So these are setting the default values for country. Add the correct return type to the function. Is international. Oh no way! No, just freaking Python-esque language. So this is a bool. No. Say is international. Okay, so if the oh, sure. I don't know why this is it this the problem? Like true? Okay, let's see. So sender, recipient, so if okay. Self.sender is not equal. I'm assuming I can do this. Self.recipient country. It's my assumption. Add the correct return types to this function signature. Get fees. Okay. so that's going to be E32. Calculate the package fees. What are these? So we have weight in grams. Okay, so it's 15. Weight in grams. What? On. Oh. Okay. Oh, I read too quick. Reading too quick. Grams or weight in grams. Okay. Bam! Crushing it. Okay. So we'll see. We'll see. This thing's gonna go off in a few seconds. Okay. So we'll see what we can get up to. Enums. Define a new type of message as used below. I have no clue what an enum is in this context. We'll look at enumerator substrate enums. Enums allow you to find a type possible variant. First, we'll define and use enum to show you how an enum can encode meaning along with the data. So enum is called options, which express that a value can either have something or nothing. Then we will look at how patterns match. So how far? Okay. All right. Oh. All right. So I think we're good. I think I accomplished 3 more down. Oh, 3 more down. So what do we take a gander at today? So day 2. What cool. So the concept the moving stuff, that was brain shattering in my mind. So the concept of moving variables and lifetime, I guess. So that was this was cool syntax. So here we looked at what? Oh yeah, maps. Oh yeah, they gloss over maps, which is cool. I'm not exactly sure the distinction between here and here. So if this is like the execute function. Yeah, that was pretty cool. Syntax is all new. So yep, maps, Rust maps. That's pretty cool. Let's see what else. Yeah, I think this stuff. Yeah, so I tried making the vec 0 and it failed because it's out of scope. So this guy's out of scope here. Oh, and you can only have one mutable reference. One mutable reference. One reference. That's pretty interesting. There's stuff tangentially that I got to see, like the derive thing. That's something that's gonna be. Oh yeah, and just structs in general, how they do classes. That's pretty cool. Yeah, okay. I wonder if there's. I guess you can do a class that's not. Oh, they even tell you the size. That's so cool. Okay. This has been something. It's been an hour. Alright. We're Rust done.